Hello there, backups. Welcome to video number 208. This one is on the and or rule of probability. Keywords are and, product, or, sum, independent, dependent, and conditional. So and in the world of probability relates to multiplying something or multiplying things together. Product is the result of multiplying, or in the world of probability is adding, and sum is also the result of adding. Independent relates to when events are not connected. Dependent relates to when events are connected to each other in some way, and conditional is just another way of saying that something's dependent, basically. So for this we use some formulas. All right, now be careful with the formulas and know when to use them, know when we're allowed to use them, etc. You'll understand when we do some questions on it, hopefully. So use the formulas if A and B are independent events. All right, so A is not connected to B in any way. All right, we can use the and rule for both events happening. So probability of A and B happening is whatever the probability of A is multiplied by whatever the probability of B is. A and B are the independent events, by the way, right? Could change in the context of every single question. The or rule, all right, there's a couple of versions here of the or rule. If A and B are mutually exclusive, and I've done a video on mutually exclusive events. If they are mutually exclusive, i.e. one thing happens and the other thing can't happen at the same time, then you can add the probabilities. Okay, so we've got the probability of A or B is equal to whatever A is plus whatever B is in terms of the probabilities. If A and B aren't mutually exclusive, and we'll have an example on that in the third question, then we've got the probability of A or B is equal to probability of A plus probability of B, and then you take away the probability of A and B. All right, so that's going to be, yeah, well, we'll do that in examples and it'll make much more sense. So in first question, there are 8 counters in a bag, 3 are red and 5 are blue, and that adds up to 8, which is good. A counter is taken, the color is noted, and then it's replaced. So a second counter is then taken. What's the probability of getting 2 red counters in a row? So the first event, or probability of A is getting a red counter from the bag. So I'm going to put probability of red is equal to 3 out of 8, because there are 3 red ones and there are 8 in total. Okay, that's event A. Probability of event B, well, it's getting a red one again, and we've replaced the counter, so the probability won't change. It's 3 out of 8 again. So that is the probability of A and B is the probability of getting a red, and we can write it and red. All right, because that's going to remind us to multiply those two fractions together, basically. So 3/8 multiplied by 3/8. And we can do it without a calculator. We get 3 times 3 is 9. 8 times 8 is 64. You might be able to simplify these fractions. You don't have to. It's the probability question. The world of probability allows us the freedom of not simplifying our fractions. All right, and there we go. That's all you have to do with a question like that. The and rule in action. Right? We use it in the world of probability trees as well, which you will see when you watch those videos. The table in the question number 2 shows the probabilities of a spinner landing on a given color. So this spinner has 4 sections: pink, yellow, green, and blue. The probability of it landing on pink is 0.5. Yellow's not there, green 0.1, and blue is 0.2. So what we should know is that these probabilities, as always, have to add up to 1. These are mutually exclusive events. You can't land on a pink and a yellow at the same time. You have to land on pink or a yellow, and not vice versa. Exactly the same thing for green and blue. So we just need to work out what's missing there with yellow. Right, so 0.5 plus 0.1 is 0.6, plus 0.2 is 0.8, and that means there must be 0.2 left to get us up to 1 whole amount. All right, you could always think of it as 5 plus 2 plus 1 plus 2 would give you 10. All right, and then divide by 10, you've got it added up to 1. Right, it's nice and simple. I don't think anyone's struggling with that. I would hope not anyway. So if you are, make sure you watch the earlier probability videos rather than this one. So what's the probability of landing on yellow or green? Yellow or green, add them together, right? So probability, we'll put yellow or green in my bracket there. This is just notation for probability. It's not the most important thing in the world. You don't have to write it, but it's quite nice to add them up. 0.2 plus 0.1, I mean, that's nice and simple, isn't it? 0.3. So probability of you landing on yellow or green, 0.3. Okay, you could write 3 out of 10. You could write 30%. It's up to you. 30 out of 100. Various different answers. So, question 3. We've got a card that's chosen at random from a pack of 52 cards, and we've got to work out the probability the card is red or a picture card. Okay. Now this is an event where those two events are not mutually exclusive. All right. You could get a red picture card, so we have to factor in that to our calculation. But basically, it starts off the same way. The probability of us having a red is, well, half of them are red, so we get 26 out of 52. Okay, the picture card probability is simple if you know your cards. Jack, Queen, King in each suit, so that means there's 12 picture cards out of all of the 52 cards that there are. And like I said, we can get red picture cards, so we have to take that probability away. So we use the formula probability of red or picture is equal to 26 out of 52 plus the 12 out of 52, but then we take away the 26 out of 52 multiplied by the 12 out of 52. The probability of A and B gets taken away, all right, from the probability of A or B. And that's how we do these ones, and that will always work for you. And when you do that, you will get an answer. We can bring the calculator in if we want for that. We could simplify those fractions down, couldn't we? But let's just do it all in one go. So 26 out of 52. Let's press that fraction button first, don't I? Let's do it on that. 26 out of 52. And then we can add that to the fraction button, 12 out of 52. And then we're going to minus, just all in one go, and then the multiplied by 12 out of 50. That's the probability of getting A and B, and we just take that away. Ultimately, you know, there's 6 red picture cards out of the 52, so we're just taking 6 out of 52 away, aren't we? So it might be an easier way to do that question, but just demonstrating how this formula will work for you. A, B, add them together, take away the probability of A and B, combination of both the two things we just did. We get 8 out of 13. Or that is a simplified answer if we've done it on a calculator, isn't it? But if we multiplied that by 4, we get 24 out of 52, wouldn't we? There you go. That might be what it comes up with if you didn't do it on a calculator. So we could have either of those answers, it wouldn't matter. And I'm going to use the one that I got on the calculator. There we go. All right.